Hello guys, this is a second part of previous videos or previous questions of quality of water, and that's video is disturbed due to some network issue. So let's continue from that point, from remaining points that where we in previous video of this series that where we discussed this question 2.54. If you haven't seen that video, please go to watch that video first, where we discuss these from these question, and we discuss that half part of this things, and we need to continue this in this video. Okay, that video is disturbed due to some network issue, and so please forgive me for that. Let's move on to our this session from here. That in that video I discussed you that if for this question that you follow a long process which I earlier discussed in that video, and or if you want to follow that the shortest and the thing which is the basic common sense, you get the answer. So that the hardness of groundwater sample found to be 420 milligram per liter as COCO3, and after mixing a softener, and you'll get a 75 milligram per liter. And here we also given that the efficiency of softener is 100%, and it's a total long process I earlier discussed in our previous video. And here we only for this question here we only discuss the shortest form, that and we get there that quality of water for four houses about 2160. So by using common sense, that for 420 milligram per liter we have a flow rate. Basically it's full flow rate. Okay, by mistaken I call it as quality of water. Sorry for that. Basically it's a flow rate. Okay, so for 420 milligram per liter we have a flow rate of 2160 liter per day. So we need to find 75 milligram per liter. So by using this you'll easily get your answer. So solve it. 2160 divided by 420 multiplied by 75, we'll get about 385.714 liter per day. We'll get 385.714 liter per day. So 385.714 is your correct answer. Okay, so yeah, this is question from 2016 of 1 mark question of GATE examination. Let's move on to our next question, which is where we discussed a sample of water has been analyzed for common ions and results are presented in the form of bar diagram. Okay, let's erase all of these stuffs. That a sample of water has been analyzed for common ions, and there's a bar diagram here. Okay, so we need to find the non-carbonate hardness. So for non-carbonate hardness, first we need to find total hardness and carbonate hardness. So we know that total hardness is due to Ca2 plus and Mg2 plus. So remember, this is given in milliequivalent per liter. So 2.65 minus 0, 2.65, and due to Mg2 plus 4.10 minus 2.65. So 4.10 minus 2.65. 1.45 multiplied by 50, and we'll get about 4.10 multiplied by 50. We'll get a value of 205. Okay, it is our total hardness. Let's find alkalinity. Alkalinity. And so here alkalinity is due to SCO3 minus only. So 3.30 multiplied by 50, and you will get value of 165. It's alkalinity. So our carbonate hardness is equal to 165. So carbonate hardness plus non-carbonate hardness is equal to total hardness. So non-carbonate hardness is equal to total hardness minus carbonate hardness, that is 205 minus 165, which is equal to 40. So option A is correct answer. Okay, this is question of 2016 gate examination, 2 marks, asked in set 2. Okay, let's move on to our next question. Basically here it's these photographs are taken from different books, so here it's not mentioned the year as mentioned here. So basically here we discuss questions from 2070 to 2020, okay, of gate examination. So first question, that the analysis of water sample produce the following results. We have a Ca2 plus of 20, Mg2 plus of 12.2, concentration 60 milligram per liter, and 36.6 milligram per liter. And for Na plus, we have given these data for K plus, similarly for Cl minus and SO42 minus, SCO3 minus, and we need to find total hardness. So it's a very simple that we already know that total hardness is due to CO2 plus and Mg2 plus. So there is a concentration 60 divided by its milliequivalent, which is already given 20, and 36.6 divided by 12.2, and multiplied by 50. So it's 3, and it's 3 to 6 multiplied by 12.2. Sorry, 6 multiplied by 50. Yeah, so it's 300. So it is 300 milligram per liter, your answer. Okay, now let's move on to the next question, that as per IS 10500 of 2012, for drinking water in the absence of alternate source of water, the permissible limit of chloride sulfate in milligram per liter. So basically this is theoretical questions, and if you see the options, basically here it asks that in the absence of alternate source of drinking water, the permissible limit of chloride and sulfate in milligram per liter. So for chloride it's 1000, and for sulfide it's 400 milligram per liter. Okay, let's move on to the next question, that a water sample analysis data is given, that here Ca2 plus concentration and its atomic weight, for Mg2 plus and for SCO3 minus, we need to find carbonate hardness. So for total hardness we have a Ca2 plus and Mg2 plus, so 60 divided by 40 by 2, 20 plus 30 divided by 24 by 2, so it is about 12.15 approx, multiplied by 50. So it's 3, and let's divide 30 from 12.15. So yeah, divide 30 divided by 12.115, we'll get about 2.46 plus 3. So we'll get 5.469 multiplied by 50. Multiplied it with 50, we'll get a value of 273.45 of it is total hardness. Let's find alkalinity. So 400 divided by 61 by 1 into 50. So 400 divided by 61 will get 6.55 multiplied by 50. we'll get 327. 327.86. So carbonate hardness is basically minimum of total hardness and alkalinity, L1. That is 273.45 is your correct answer, milligram per liter SCaCO3. Okay, so your answer is 273.45 milligram per liter. Okay, yeah, let's move on to our next question. That is, analysis of water sample revealed that the sample contains of the following species. We have a given sample here: CO3 2 minus Na plus all these samples, and we need to find that concentration of which of the species will be required to compute alkalinity. So for alkalinity, we need CO3 2 minus. We get alkalinity from SCO3 minus, OH minus. Yeah, from only these things. So here CO3 2 minus, H plus SCO3 minus, OH minus, H plus H2CO3, SCO3 minus, OH minus, CO3 2 minus 2, CO3 minus, SCO3 minus, OH minus, and CO3 2 minus, H plus H2CO3, SCO3 minus. So here it is, here it is, here it is. So this option is correct. Okay. We have there's a concentration of a species which we need for compute alkalinity. That's CO3 2 minus, H plus, SCO3 minus, and OH minus. So this is our correct option. Okay, let's move on to the next question. That an amount of 35.67 milligram HCl is added in distilled water, and total solution volume is made to 1 liter. Okay, and the atomic weight of H and Cl is 135.5, obviously, and neglecting the dissociation of water, the pH of the solution is. So basically, we have given up about 35.67 milligram per milligram HCl, and we have atomic weight H plus Cl. So give find HCl that it's about 36.5. So 35.67. Wait a second. So 36.5, 36.5 gives HCl of 35.67 milligram. So 35.67 divided by 36.5. Let's calculate it this. We get a concentration. Hey. We need to calculate this, that 35.67 divided by 36.5. We'll get value of 0.977, and we need to find its pH. So its pH is in log. Take it as log of 0.977. So 0.977, take it its log. 0.977. We need to solve this by taking its log, value, and you'll get your answer. Okay. Yeah. Give me a second. Let me calculate this. Give me a second. So it is basically here it is in milligram. So we need to change it in see, and here we need to find this. So calculate it. Let's calculate this 0.977 and we'll get a value of minus you'll get plus 3.010105. So yeah, this is option is correct. So 1 mark question. Let's move on to our next question, which is where we need to find alkalinity of water in equivalent per liter, and we have given this equation that has CO3 minus plus 2 CO3 2 minus plus OH minus and minus H plus, where this bracket represent the concentration in mole per liter. Okay, and we have a concentration of SCO3 minus 2 into 10 to power minus 3, and for CO3 2 minus 3.04 into 10 to power minus 4 mole per liter, and we have pH of water 9 and atomic weight, respective atomic weight is given. So if concentration of OH minus R and H plus are neglected, the alkalinity of the water sample. Okay, so concentration of OH minus and H plus are neglected, we need to find alkalinities. So by using these two only. So we have a concentration of SCO3 minus 2 into 10 to power minus 3. So first you need to change it into milligram per liter. So multiply it with their respective atomic weight, which is 61 into 10 to power 3. It's about 122 milligram per liter. And similarly with CO3 2 minus, that 3.04 into 10 to power minus 4 multiplied with its atomic respective atomic weight. So which is as 48 plus 12 multiplied 60 into 10 to power 3, and we have calculated, we will get value of 18.24 milligram per liter. And after this, everything is be simple, that 122 divided by 61 by 1 multiplied by 50 plus 18.24 divided by 60 by 2, that is 30 multiplied by 50. And let's calculate all these values, that 122 divided by 61 will get obviously value of 2 and 18.24 divided by 30 will get value of 0.608 multiplied with 50 plus 100. So we'll get value of 130.0 135.4. So yeah, our option D is correct answer. Okay, so this is how we solve this question. This is of 2 marks question. Let's move on to the our next question, that the ion product of water PKW is 14, and if rainwater sample of 5.6, the concentration of OH in the sample in what it is in 10 to power minus 9 mole per liter. We need to find the concentration in 10 to power minus 9. So here we have a ion product of given 14, and we have a pH pH of 5.6. So we need to find concentration of OH minus. So we get OH minus of 14 minus 5.6, which is 8.4. Okay, and we need to find concentration of OH minus. So OH minus is 10 to power minus 8.4, and we need to find it in as 10 to power minus 9. So 8.4 plus 9 into 10 to power minus 9. So it is about 0.6 to the power 10. So it's about 3 point minus 0.6. It's about minus not 0.6, about 3.98 into 10 to power minus 9. So 3.98 into 10 to power minus 9. So 3.98 into 10 to power minus 9 is your correct answer. So yeah, this is it. This is all about the previous year questions of quality of water, and this is questions from 2008 and 2008 to 2000 of 2020. Okay, this is all about the questions of quality of water. Okay, we'll meet you very soon for in the previous year questions of other subjects. Till then, do a lot of more questions of GATE examination, and take care, and thank you so much for watching this video.